Hello students, so today we are going to learn about application of linear algebra to chemistry. So let's go. So we start with introduction. So as we know, mathematics is very essential in many fields including natural sciences, engineering, medicine, finance and the social sciences. So mathematics is used widely in other sciences fields including chemistry. Yes, of course, for example, balancing the chemical equation, we use math, calculating energy in reactions and many more. Other than that, mathematics is very important in industries. Why? It is very important to calculate the exact amount of production substances. It is because overproduction may increase the cost and resulting a big loss to the company.
In this project, we are using Gauss elimination method. Gauss elimination is a method for solving a matrix in the form AX equal to B. There are a few steps to perform Gauss elimination. Step 1. Starting with the system of below matrix equation. Step 2. Compose the augmented matrix equation. Here, column x1, x2 until xk is carried along for labeling the matrix row. Step 3. Perform the elementary row operation, which is ERO, to put the augmented matrix into the upper triangular or row echelon form. And the last step, step 4, solve the equation of k row for xk, then substitute back into the equation of k minus 1 first row to obtain a solution for xk minus 1 according to the formula.
Assalamualaikum warahmatullahi wabarakatuh. My name is AYUNI and I am going to present for result application 1 and 2. Okay, for application 1, we have a statement about ethane, that is a gas similar to methane that burns in oxygen and give carbon dioxide gas and steam. So the steam condenses to form water droplets. The chemical equation for the reaction is C2H6 plus O2. We get CO2 plus H2O. And what we're going to do is to balance the equation. Step 1. We have to insert unknown by multiplying the reactants and product to get the equation form as below. So we have W, X, Y, and Z. For step 2, we compare the number of carbon, oxygen, and hydrogen atoms of the reactants with the number of products. So we obtain three linear equations, that is here, here, and here. Moving on to step 3. For step 3, we rewrite this equation in standard form, and we can see that we have a homogeneous linear system in 4 unknowns, that is W, X, Y, and Z. Now is step 4. We rewrite the equation or system in matrix form. So we can see here that we have the augmented matrix. So we solve the augmented matrix from step 4 using echelon form. As you can see below is the two process in solving using echelon form. As you can see in step 6, the solution is found from the corresponding equation, that is equation 1, equation 2, and equation 3. As you can see in step 7, we use elimination method to eliminate y. So we subtracted equation 3 from equation 1 and we get z equals to 3w. And step 8, we substitute the value of w into equation 1 and we get y equals to 2. And we substitute the value of y and z into equation 2. So we get x 7 over 2. Since z is an arbitrary constant, we let z equals to 3. So we get w equals to 1, x equals to 7 over 2, and y equals to 2. So our balanced equation is C2H6 plus 7/2O2, we get 2CO2 plus 3H2O. That is the answer for application 1. So now is the result for application 2. As you can see, in using linear algebra, chemists can add exact amount of compounds in order to get the proper result without any waste product. So they can be very conservative with the products that they have. Furthermore, this can be used to find out what a compound is made up of, as you can observe in the following example. If we are given the amount of moles of a chemical combination, we can figure out each chemical's weight per mole in order to find out what chemicals were added. So, in the next slide, we are given 4 combinations of the same 4 chemicals, the amount of each chemical in moles, and the net weight of those 4 chemicals combined. As you can see below, we have 4 bowls of 4 chemicals combined with their weight. Step 1 for the solution is we set up a system of linear equation. So we let chemical 1 equals to A, chemical 2 equals to B, chemical 3 equals to C, chemical 4 equals to D. And below we can see the system of linear equation. Moving on to step 2, we can solve the system of linear equation using RREF. But first, we have to make the system of equation into matrix, as you can see below. This is the equation that turns into matrix. And below you can see the step in solving the matrix. And this is the last 4 steps, and when we put into RREF, we get the matrix below. So from that we know that chemical 1 is 3 gram, chemical 2 is 5 gram, chemical 3 is 8 gram, and chemical 4 is 11/3 gram. That's all from me. I hope that you understand what we have discussed in application 1 and 2.
As a conclusion, this work presented a formula which is a systematic approach for balancing chemical equations. To solve this problem, a balancing technique based on augmented metric protocols was described in this work. It was the best way to explain through demonstration in the methodology. The metric procedure as the most general tool for balancing chemical equation is demonstrable. In other words, the mathematical method given here is applicable for all possible cases in balancing chemical equations. Besides that, the method that used is based on the Gaussian elimination method and augmented metric protocols. The metric procedure is an effective method for balancing chemical equation reaction, which is illustrated through different problems. Therefore, the mathematical method presented in this paper was more applicable for all cases in the chemical reactions. The results indicated that there is no any contradiction between the various methods that were applied to balance the chemical reaction equation and the suggested approach. As well as the work conclude by demonstrating how this can be accomplished in different widely with adopted software packages such as MATLAB software and Maple software. The chemical equation problem can be solved easily using on the Gaussian elimination method and augmented metric protocol with the help of the software packages.